What's up, folks? Today we're going to assemble the main board for the PKE meter from MSH Design Studios. Let's get started. Okay, so this is a pretty straightforward build. It's actually one of the more simple builds, despite it being the biggest PCB. And it's really just because you plug everything in the right spot and solder it, and that's it. So you'll need your PCB, obviously. You'll need your Arduino Nano. If you ordered a kit from me, then you got one of these that's got the code on it already. If you order any of the boards from me, I'll give you the code. Just ask. Let's see. You'll need a look at my list, make sure we got everything. So you'll need 2 shift registers, and these are 74HC595 shift registers. And I'll have these on my store if you want to buy them. Otherwise, you'll probably be stuck with buying like 25 or 15, and no one really needs that many shift registers. You'll need 2 1,000 ohm resistors. So be careful if you don't buy them from me or you don't get it in the kit. Be careful which ones you get. I ordered several different kinds off of Amazon, and they were enormous, and they did not fit in the board. So just be careful. These are the smaller ones. You'll need your DF player. I'm going to end up doing a video on just the DF player because it is a nightmare to work with. You can ask Nathan and Ben Dobson. What's up, guys? You can ask them how much of a nightmare this was for me. This just trying to get this to be stable. I fried several boards and several Arduino Nanos, and I'll explain that when we get to it, why that's such a problem. Also, if you don't get this from me, make sure that you get it from either directly from DF Robot, who they're the ones that make these. There's a lot of fake ones out there, a whole lot of fake ones, and the fake ones are hit or miss. Like, you just don't know if they're going to work or not. I have used some that do work. I have used some that absolutely do not work even halfway. If you order just some random ones on Amazon, you are going to be out of luck if you get them and they don't work. I'm not going to be able to help you troubleshoot those. I ordered in bulk from DF Robot once, and they sent me a shipment of some that didn't work. They refunded my money, and then even sent me like a bunch that did work. I don't know what the mess up was there, but that was kind of weird. DigiKey, that's where I usually buy these directly from them, or I get them from DF Robot. But DigiKey, if you buy a DF player on there, you're probably going to get a good one every single time. So some bit of advice there. The last part that you'll need for this is a 1N4001 rectifier diode. And when we get to the DF player, I'll explain why this is necessary. This took some figuring out, and this one little thing makes the DF player more stable. So we'll get to that in a minute. All right. First I want to kind of go over the parts of the main board here. Obviously this is in the shape of the inside of the PKE meter. The new version of the Iona style shell that MSH Design Studios has done there's going to be this little section right here is actually going to be dremeled off on both of these sides, and I'm planning on doing that myself, so people won't have to worry about doing that when they get them. But you know, props to Nathan at MSH Design Studio for you know, going over and over the design, trying to make it as close to the Iona as he can. Now that he has an Iona, he's worked really hard at getting that as perfect as he possibly can. So, you know, at this point, I think it's safe to say that his model is probably the closest to Iona you'll ever get if you don't get an Iona. So starting up here at the top, this area right here is for one of the shift registers, and you have a second one here. Now these power all of the LEDs, and this is really what makes this whole thing possible. Shift registers, they make it possible for you to control a lot of stuff with just a few wires, just to kind of break it down easily to understand. Each one of these holes, almost all of them, coincide with an LED on the wings. And then there's a what's called a clock, a latch, a data pin, and then a reset. And it's the same here. This is for the main screen or the pattern screen, whichever you want to call it. And you'll notice there's a little kind of, make sure you can see that. There's this little kind of half moon shape right there, and if you look on the shift register, I'll probably put a picture up because I don't think you can see that, but at the very top of the shift register, right there at the top, there's a little notch. You're going to put that in place on the top with that notch in the same place. So you're always going to make sure that's in the right, going in the right way. Now these are Texas Instrument shift registers, and they're pretty good. I've never had any problems with any of those. They work great. Okay, so across the top here you have, these will connect to your main screen or your pattern screen. I have that assembled here. And you're going to need to line up those numbers on the back here with the numbers that are right here. So, for instance, 7 is this gray color, and you're just going to solder that right there. And obviously, the wires don't have to be this long. Like that's way too long. You're only going to actually need about that much wire. Another possibility there is to actually use DuPont connectors, or yeah, I guess DuPont connectors. I don't know what other kind of connectors would fit there. You could try some other types, but I've used DuPonts and they fit, but you have to bend them at a little bit of an angle. But it works if you want to try that. So here, this is where your wing LED pattern board wires go, and I have that here. So this will go basically right there. It kind of hovers over that area. You actually don't need that long of a wire on that, but what I usually do is I'll take this wire and I'll kind of loop it around a couple times so I have enough there, really, so it's not putting any strain on anything. But you do have to make sure that the numbers that you have here on the pattern board, or the wing LED board, those numbers coincide with the numbers that you have on the main board. So I know that number 1 is red, and so that red wire is going to go in that first hole. And you can use either one of these. You can use the smaller hole or the bigger one. The bigger one, originally I had planned on using DuPont connectors there, but there's really not enough room or clearance with the wings there. If someone can make that work, awesome. I'd love to see it. But I'm fine with just like soldering it straight into these right here. Now I'm not going to assemble the PKE in this video. This is strictly just the main board. There's going to be another video that kind of brings everything together. That's going to be a pretty lengthy video. It may need to be like 2 parts, but that video will be everything kind of being put together. Okay, so continuing down the board here, we're going to look at the rest of it. This is where your Arduino Nano goes. Pretty self-explanatory. I have a note there that says that. You have a 1000 ohm resistor there. The diode goes here, and there's another resistor that goes right there. Now, before I go much further, let's look at the diode real quick. So the diode, if you can see that or not. Yeah, that's a little bit better. So that diode has a little gray end on it. So there's one end that's gray, and the other end doesn't have that little gray strip. You'll see on the main board, on the pattern board right there, there is a strip. So you got to make sure that that diode is put in the right way, because this particular diode does not work the other way around like a resistor does. You have to put it in one way. So that is the way that it goes, with that gray strip lining up with the strip that's on the image of the board on the silk screen. That is very important, or the DF player will probably not work. There is one more thing that I forgot that you do need for this. Now, this can help you for 2 different things on the main board. There's actually another thing that I'll cover on this, but I'm not going to install it on this either. There's a 470 UF 10 volt capacitor. Now the reason I have a capacitor, there's actually 2 places on the main board that you can put a capacitor. There's one right here, and then there's one right here. Those are meant to use either one, not both. You get one capacitor, you can put it in one place or the other, but not both, and I'll tell you why. I found out that one of the servos that I was using had what's called the jitters. It was jittering a little bit. It ended up being just a very cheap servo is what it really boiled down to. But I did find that if I used a capacitor, it was a lot better off. It was a lot more stable. So I put this capacitor pad or solder place, whatever you want to call it, closer to that servo in case you have a servo that is a little unstable. This will help. The other thing is that I found that the capacitor helps for a DF player that you're having voltage problems with. And I'll get to the DF player in a minute. But there's a place for you to put the capacitor in there. Now the capacitor is pretty much like the LEDs. The long lead is the positive, short is the negative. And I have those marked on here. I have a plus and a minus. Just remember, it doesn't take 2 capacitors, it takes 1. You could probably go with a very, very small capacitor and get away with using 2 if you want. I haven't tried that, and I'm not really interested in trying because I don't need to. My PKE is pretty stable without having to use 2. But you could give that a try if you need to. So if you buy one of my kits, I'm going to send you a pretty good servo that's got metal gears in it. If you use one of the servos that you can get on Amazon for super, super cheap, it's got plastic gears, you're probably going to have some jitters and things. So if that's your only choice, then try a capacitor. You don't actually have to use one of these if you wire everything right and you buy one of my kits. You don't usually have to use one of these, but I do include one because I feel like it's a little bit more stable. Alright, so now we get to the DF player. Everyone has problems with the DF player, and I'll tell you why. First off, the DF Robot website has the working voltage for this wrong. I think they say about 5 volts. The truth is that running this at 5 volts will continually reset this or possibly damage it. I've damaged and burned out I don't know how many of these things trying to figure out how to get this to work on a battery inside something this small. The trick is, so let me back up. We're running a booster board inside this. This is actually the booster board right here. I don't know if you can see. That's it right there. That's it. We're running a booster board inside the PKE so that the servo will run right, so that the LEDs will run right, because the Arduino is very stable at close to 5 volts. What I found though is that the DF player is not stable close to 5 volts. After researching and reading and looking at other people's projects that they use the DF player on, what I found out was that this actually runs better closer to 4 volts than it does 5. Part of the issue with this PKE meter is that you have a servo, and when servos move, voltage spikes. When that voltage spikes, the DF player can actually reset. So if the voltage spikes higher than 5 volts, then you're going to get a reset, the sound will quit, and you'll have to restart the PKE because you won't have any sound. Yeah, so when you're handling this, be very careful. There are tons of resistors on the back, and then you have your circuits. This one, I think one of these is responsible for reading MP3 compression, and I don't know which one it is. Yeah, so on the main board, you have a place specifically for the DF player. I've got some pin notes here. They're not really that important. There's a couple on the back just for the speakers, so you can know which those are. Speaker pads are actually down here, but I have them labeled on the back just so you know. But it just plugs in, just like that, and then you just solder it. Some other things that I want to highlight here, though, is this is where your servo is going to sit right here, obviously, but your servo connections are right there. This is your Bluetooth module connections, and I'll show you how to hook that up and configure it and everything after we get the rest of the PKE installed. You don't have to have this Bluetooth module in there, but some people will like to play around with that. So. And then you have your top board connection here. So the top board, I don't have one of those with me, but the top board is responsible for basically your touch sensors. It has an LEDs on it that light up depending on which pattern you're using, and depending on which touch sensor you're using, a red LED will light up when you touch it, and that's what that is. So you can actually get your main board working, and you can touch the there's a button 1, and button 2, and you can actually touch those pins right there, touch those pads to make the PKE trigger as you're putting it together. It's a good idea to test that stuff. I think that's it. I think that's everything. I'll cover what's down here just real quick. So these are your speaker connections right here. It's really just speaker 1, speaker 2. This is mono, it's not stereo, so it doesn't really matter which side is which. And then right above the speaker is very small, but this says optional amp. If you buy a kit from me, you'll get that amp. It's a really small green chip, and there's actually a place specifically for it in the shell. I'll see if I can throw a graphic up so you can see that. But that is where the optional amp goes. It is louder when you have the amp, so it's a good idea. Especially if you're going to use this at cons and stuff, it's pretty loud, so it'll make you heard for sure. So I've got pot right there. I used to have potentiometer across the top, and I gouged that out right down there so that the potentiometer actually sits down into the model better. This is the power for the pot. This is the signal, and that's the ground. Originally, I wanted the pot to basically plug right into that, but it's just not possible the way that it has to sit in the PKE. It's just not possible, so there's some very small wires you have to connect for that. But I'm not going to cover that today. I'll cover that when we get closer to the full assembly, which I think that video is probably going to have to be at least 2 parts because it takes a while to do that. Right now, we're just getting the individual boards done. And then lastly, this is the battery connection and the ground connection. Now, I say battery, but this is really where your booster board connects. On the booster boards that I recommend using, on this booster board right here, you have 5 volts, negative and positive right here. And then you have battery in, positive and a negative. So the battery goes in on this side, and the wires come out here to go to your main board. So when I say battery on the main board, that's what I'm talking about. It comes from the booster board. And yeah, I think that's it. I think that's everything. These turned out, this is the, let's see, the 6th version. I've got a real small font down there, version 6. This is the 6th version of this main board that I did. The first version it was a disaster. The second version, I got pretty much all the LEDs on it working. The third version got pretty much everything but the DF player working. Let's see. I know the version before this one, the 5th version, was pretty close. That was pretty close. There were some minor changes that I made on this one, like adding another place for a servo over here, and then I added back in the other 1,000 ohm resistor for the DF player, and then I took out the thing at the bottom here. So this is the final version of this. When I get rid of all these boards, I'm actually going to do a second version of the entire thing, and I'm probably going to phase out using the Arduino Nano. We're going to switch to a ESP32 board. But I haven't really started on that yet. I've got a lot of other stuff in front that I'm working on. But yeah, so let's put this together. As with the rest of my tutorials, we've got our 0.3 millimeter solder, we've got our tip tinner, and soldering iron, and we've got helping hands. Alright, so what we're going to do now is just fit everything into place. Starting with the shift registers. And what I like to do, remember I said tweezers are handy. I would get a good set of tweezers for this. You want to make sure with the shift registers that this notch is at the top. And then when you put it over here, the notch is going to be right here. So we'll go ahead and put that one in. You might have to just squeeze the legs on it just a little bit. There, looks just like that. Pretty simple plug and play on that. Now if you turn it over, what I usually do, and I've put these together where I thought that I soldered it, and I had to put a lot more solder on it than I really felt like I should have, just to get the LEDs to light up properly. But what I found is that if you turn it over and you go down the line here and actually bend these legs down, I'm going to use the other end of my tweezers here. Bend these legs down. You will have no problems whatsoever with those LEDs. You want to make sure that the board has really good contact with them, and you actually have more room to solder when they're bent down too. So they'll make really good contact with the board, and you'll have a good place to solder. Just like that. So you're going to bend those down just like that. So we're going to do the other one now. Again, make sure that that notch is in the right place before you do this, because once you bend these down, it's not easy to get these back out. Alright, that's it. That's it for the shift registers. Yep, so now they're both bent down. That's ready to solder. It's that easy. Okay, we'll just work our way down. We've got our Arduino Nano, and this you'll have to look at the Arduino Nano. I've got the pins labeled on here, but you need to make sure that this is in the right way. Pin 13 and 12 are at the very top, and you have a RX and TX at the very bottom. And this just, it's plug and play, just like the shift registers. You're just going to plug that in. Just like that. Fits into place. When you plug it in, you're going to see down the side right here, you've got the numbers of the pins. Make sure those are the same. You can get other Arduino Nano looking boards that are very similar to this. The pins will not be in the same order. This will not work. So make sure this is an Arduino Nano. There are lots of people that make them. I don't care which kind you get. If you don't get it from me, I don't care which kind you use, as long as it works, for one thing, obviously, but it has the pins in the right order. And it should if it's a Nano. Now, obviously, you don't really need these pins on the back jutting out like that. So after we solder it, I'm gonna trim these off, because it'll sit down into the board better that way. But that's it for the Nano. Let's see here. The next one we want to do is the diode. Now, remember I said the diode, which goes right there. The diode has to go in a very particular way. You've got that silver band at the top, and I've got the silver band labeled right there. So we're gonna go ahead and bend these leads down. This isn't like you see these leads are the same length. That's because there's not a positive and a negative side. That's not what this type of component is. This diode inhibits voltage from getting to the DF player by about 1 volt. And that's what its purpose is. The booster board brings in voltage at 5 volts. This diode stops 1 volt, takes away 1 volt is a better way of saying it, from the voltage going to the DF player. It actually ends up not really being a volt. It's like 0.8 of a volt, but it's enough where if there's a voltage spike from a servo, it's not going to reboot the DF player. So it makes it just about as stable as you're going to get in this tight of a space, which was really hard to figure out. I burned a lot of boards and a lot of Arduinos and a lot of DF players. I got a basket full of components that are fried, which is really unfortunate, but that's the way the cookie crumbles. Alright, so we're just going to bend these leads down, just kind of make it like that. We'll solder these and then just clip them off. Let's see. Resistors. Got our 1000 ohm resistors. We got 2 of those, and those go right in here. So we're going to bend those down. Again, doesn't really matter which way you put these in. And then the other one goes along the side right here. If you've done other projects with a DF player, you've probably seen diagrams that show 1000 ohm resistor on both the receiving and sending lines, or the RX and TX lines, to the DF player. And really, the only one that really needs the resistor is the receiving. And that is to protect the DF player from overvoltage or damaging the DF player. When the data line, the receiving data line, receives data, it can sometimes get voltage spikes from the Arduino or some other things, which will reset the DF player and cause it not to function. And that's really what that's for. So just move those out of the way. So we've got those bent over in the back like that. And then the last thing, oh, nope, sorry, capacitor. Got the capacitor. I have been putting the capacitor near the servo, but I think this time I'm going to put it right here, which is, unfortunately will cover up the no-ghost, because when you solder that in, you need to bend it over a little bit. So put it right there. The Bluetooth module actually will sit kind of right in there. So flip this over, bend those down. Yeah, so it'll look like that. Okay. DF player. So the DF player is the last one, and I've got the pins labeled here. That's going to go with the SD card pointing down. And these are, you again have to, kind of like the shift register, you have to squeeze the legs just a little bit to get it positioned. There we go. Just like that. So that is all of the components of the main board. They're all in place. Now the only thing left to do is just solder it all, and that's it. So we're going to clip this on to our helping hands. I realize this is upside down. Well, yeah, I have to do it this way. I apologize if you hear some background noise too, because I've got my resin printer printing right now. I'm printing a PKE shell. Surprise, surprise. All right. So we're going to do the DF player now. Before I start that, I want to show you on the DF player area, the ones that are marked with labels are really the only ones that we need to solder. Both grounds, the speakers, send and receive, and then the power. So let's do that. All right. So here's what we have so far. We've got shift registers done across here, and then we've got our DF player. Now you can clip these off here. Once you finish everything else, you can also clip the Arduino pins off because you want this to sit as flat as possible in the model. So let's get the resistors and the diode, and then we'll do the nano last. And the capacitor. I forgot the capacitor. We'll get the capacitor too. Okay. I think that's it for those components. You've got the capacitor, you've got the diode, and both resistors. So you can actually, to get those out of the way, let's go ahead and clip those off here. Get nippers. Easily one of the most used tools in my workshop. Okay. Yep. So just about there, just about done. Just the Arduinos left, and then we'll clip these pins off. There's a lot of pins to do for the Arduino. Just make sure that you get to each one, because we actually use almost every single Arduino pin. So take your time. The Arduino is basically the brains for this entire thing, so if these pins aren't soldered well, then, you know, nothing's gonna work right. So make sure you get plenty of solder on there. Don't use don't obviously like cake it on or anything. Just make sure that, my rule of thumb is usually as long as I can't see through that hole that the pin's in, then I'm probably pretty good. You need some solder in there to make sure that it's making contact with the board. We don't talk about shorts very much. I haven't mentioned them in any of the other videos, but this is one board you need to absolutely make sure that there are no shorts anywhere. And basically what I mean is there's not solder running between pins. That'll ruin your day. Go grab yourself a beer or something, because you just did a lot of soldering. But you can check over it now. Look to see if there's going to be some places that you need to put a little bit more solder. Looks like. Okay, I think we're good. Alright, well, now, first let's take a look. All that's really left to do is clip those off. I'm actually gonna grab some safety goggles here, because these little parts tend to go everywhere, and I would not want to catch one in the eye. Okay, so looks like clipped all the pins off. Everything looks, I can turn the board, you can see all the pins are cut off there. You can actually cut those off too, but we'll wait to do that later. So at this point you can actually you can test the DF player, and I'm gonna try to do that. So I've got the SD card in with all the sounds on it. There's two options to test the DF player. I can supply some power to the board, or I can do the easier way, and I can plug up the Arduino with a USB data transfer cable. Now this will, if the DF player works and if all your wiring is good, you should see a blue light come on the DF player, and you should see lights come on the Arduino. You can't power the whole PKE with the USB on the Arduino. This is just giving it a power source. If you had all the LEDs and the servo and everything, this would not be nearly enough power, but we're going to give it a try and see what happens. Alright, so here we go. Remember, you'll look for the blue light on the DF player. There we go. So if we had a speaker hooked up, it would play the boot up sound for the PKE. I don't think this will work, but we'll give it a try. I'm going to try to touch the button pin. Oh, it does. And that's exactly how it works. So I'm touching the button, or the touch sensor. I'm going to touch the other one, and that fires off. And then turns off when you take your finger off. So it works. Sometimes I'm still surprised that it does, but I put an awful lot of work into this. So that's it. The next step after this is we've got one more board tutorial, and that's the top board, so that'll be the next tutorial that comes out. And then we'll have several parts that will be assembling everything together. So if you've gotten this far, good job. You're close. I know it's a lot of work, but it'll pay off, and everyone will be super jealous of your PKE meter. So for Pixel Prop Store, I'm Jason Glisson. I'll see you later.